Okay, I'm sorry for that little mix-up I had yesterday on sending you all the wrong document. I sent you the document, or part of the document was for the 10-day course, which I finished a couple of weeks ago, or a week ago, and so hopefully we're all in tune now to use the 9-day copied document or classroom, which combines the last two um, into one day. So, and we'll have the final on day 9 instead of day 10. So please make sure that you're using the proper classroom. Okay, it's the one that's EUBYJTA. All right, so we're good there. So if you followed yesterday, you know that you now learn that we have N-type material, we have P-type material, and when we join them together, we make what we call a p-n junction. The p-n junction is used in almost all of the solid state components. Okay, so basically, it's when you join an N-type material with a P-type material, something happens at the interface. You create a depleted region, which essentially turns out to be have capacitive relationships. All right. So today we're going to use that p-n junction in two different ways. First, as the regular diode. A diode is a component which takes an AC signal and cuts off the lower half of the AC signal so that you're just left with the top half of the waveform. So you're left with a pulsed DC, essentially, coming out of a diode. Now, the way that it's done is you have to bias the voltage on it. You have to make sure when you get that pulse that you put the positive side on one side and the negative side in only one specific way, which will give you what we call a forward bias. All right. So that will allow current to flow only in one direction. When it tries to flow, if you try to flow it in the opposite direction, it does not go until you increase the voltage substantially to where you get what we call a breakdown. The junction falls apart, and or actually leaks in one case, or falls apart in another case, and you get current flowing in the opposite direction. And if that is high enough, it'll damage the diode. Okay, you don't want to do that. The way that the other method of creating the diode so that you allow current to go in the opposite direction is what we call a Zener diode. Zener diode then will allow current to flow in the opposite direction, but only if if the voltage is of a very specific voltage. All right, called a Zener voltage. And basically, that's the way it's used. It's that particular Zener diode is made to be used in a reverse voltage condition so that you maintain a certain voltage called a Zener voltage, which is used widely in power supplies where you have some voltage being brought down by a transformer. So you get a lower voltage waveform that's AC, pass it through the diode first to a diode circuit to get pulse DC, and then you want that pulse DC to have a specific voltage, so we place a Zener diode in parallel to that to give us an output that will be a certain voltage. Okay, that's the purpose of a Zener voltage. So today is all about diodes, and tomorrow we will expand our knowledge of diodes.